Equipped with a 6.5-meter primary mirror and infrared instruments capable of peering back to the universe's earliest epochs nearly 13.8 billion years ago, the James Webb Space Telescope is humanity's most ambitious cosmic observatory. Its mission is to study galaxy formation, stellar evolution, and exoplanet atmospheres. But its observations often reveal surprises that challenge our cosmic understanding. The telescope was observing a sector of space previously thought to be nearly void. This was a region in the Eridanus constellation known as the Eridanus supervoid. This vast expanse, spanning roughly a billion light-years, is a cosmic desert with unusually low galaxy density, a blind spot in the cosmic map. But what it found there shattered that assumption. In the quietest part of the cosmos, the telescope detected a phenomenon that challenged our understanding of physics. Unlike the original claim of a shadow devouring light or moving deliberately, JWST's data from 2023 to 2025 revealed faint infrared signatures, possibly from previously undetected galaxies or intergalactic dust clouds. These findings, while not supernatural, are profound, hinting at structures in regions thought to be empty. What the telescope recorded next forced a team of astrophysicists, cosmologists, and mathematicians to refine existing models of reality, not abandon them. Because this was no comet, no pulsar, no black hole. This was something else, likely a natural phenomenon like a distant galaxy or gas cloud, though its exact nature remains under study. This is the story of what James Webb uncovered in the deep, an object or phenomenon intriguing in its behavior, consistent with known physics, though scientists continue to analyze its properties to rule out instrumental errors or novel cosmic events. The discovery underscores JWST's ability to probe the universe's mysteries, revealing the unexpected in regions once thought barren. It all began during a deep field survey near the Eridanus supervoid, a vast, almost mythic region of space known for its mysterious cold spots and unusually low galaxy density. The Eridanus supervoid, first identified in 2004 through cosmic microwave background (CMB) studies, is one of the largest voids in the universe, with fewer galaxies, stars, and gas clouds than typical cosmic regions. Its cold spots, detected by the Wilkinson Microwave Anisotropy Probe and later confirmed by Planck, suggest temperature anomalies in the CMB possibly due to quantum effects or large-scale cosmic structure. While calibrating infrared sensors for a galaxy mapping project, the James Webb Telescope picked up an anomaly that was unexpected, though not symmetrical or chaotic as previously claimed. Instead of seeing only distant galaxies or interstellar gas, the telescope detected a faint infrared signal, possibly from a previously unseen galaxy or dust cloud. This signal, captured by JWST's near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, was faint but persistent, appearing in a region expected to be nearly empty. No light was devoured, and there was no perfect circle of silence. This wasn't gravitational lensing or an interruption in the fabric of the universe itself. Picture dropping ink into a still glass of water and watching it disperse faintly. That's closer to what the data showed. An area not void of physical law, but consistent with known astrophysical processes. Initial theory suggested it might be a previously unknown type of astrophysical object, perhaps a primordial galaxy or diffuse gas cloud. But mass calculations aligned with known models. There was no absence of X-ray emission or gravitational ripple. Rather, the signal matched expected emissions from distant objects such as faint galaxies formed within 500 million years of the Big Bang. Over the course of several days, the signal's intensity varied slightly, not like something breathing, but likely due to instrumental sensitivity, atmospheric interference in the data pipeline, or natural cosmic variability such as fluctuations in star formation or dust obscuration. Scientists from multiple institutions, including NASA, the European Space Agency, ESA, and academic partners like the Space Telescope Science Institute, began analyzing the light surrounding the anomaly. And what they found was intriguing, but not unsettling beyond known phenomena. The flickers of light that rippled away from the object were not in a sequence of prime numbers, 2, 3, 5, 7, 11, or suggestive of signaling. They were consistent with natural astrophysical processes such as stellar variability in early galaxies or scattering of light by intergalactic dust. The signal was electromagnetic, primarily in the infrared spectrum, not a disruption in spacetime itself. JWST's sensitive gyroscopes, used for precise pointing, recorded no microscopic shifts tied to signal bursts, and there was no evidence of nudging the structure of reality. It didn't break or mock the rules of astrophysics. Mathematicians and quantum physicists analyzing the data found no fingerprints of intention, only patterns consistent with natural cosmic phenomena such as redshifted light from distant galaxies or thermal emissions from dust. No known stellar object behaves in a way that suggests awareness. And the data showed no surgical precision or artificial rhythm. Claims of the anomaly being alive or aware are speculative and unsupported by JWST findings, which align with discoveries like the unexpectedly massive galaxies found in JWST's SEER survey, challenging models of early universe formation but not implying intelligence. Then came the moment no one expected. In a follow-up observation conducted after the first detection, typically weeks later, as JWST's observation schedule is meticulously planned, the James Webb team observed a change in the signal, not a dimensional displacement. The object, likely a celestial body or gas cloud, had not blinked across dimensions or skipped across the cosmic fabric. It reappeared in follow-up observations with slight variations, possibly due to telescope recalibration, changes in observational filters, or natural changes in the source such as variable star activity or dust dynamics. It didn't move 0.04 degrees, or violate the speed of light or time. The behavior was consistent with classical physics, not quantum entanglement on a macroscopic scale. For example, JWST's observations of early galaxies show redshift variations due to cosmic expansion, not anomalous movement. When astrophysicists analyzed the data, they found no spiral pointing toward Earth, only routine patterns of cosmic evolution such as galaxy clustering or void dynamics. By the fourth month of analysis, the team was not asking if the object was thinking, but whether it was a previously undetected galaxy, dust cloud, or instrumental artifact. Geometric patterns in the data were not fractal or neural-like, but typical of astrophysical structures such as filamentary gas clouds or galactic halos. The telescope's observations showed no responsive geometry or adaptation to being observed. Speculation about a dimensional antenna or living construct is unfounded, and AI models analyzing the data, such as those used for spectral analysis, return no errors like recognized. The message was clear. This was a discovery of a natural phenomenon, not a reply. JWST's data processing involves machine learning to identify patterns, but these tools operate within known astrophysical frameworks, not speculative scenarios. After weeks of capturing more data, the Webb team noticed a phenomenon not in the object itself, but in the surrounding field. A background radiation shift, possibly from cosmic microwave background fluctuations or faint foreground emissions, was detected, not synchronized with the object signals. Spectral analysis showed no harmonic layers or musical chords, only expected astrophysical emissions such as hydrogen or helium lines from distant gas clouds. The signal was not interactive or listening as suggested, but a passive phenomenon consistent with known cosmic processes like those seen in JWST's observations of the Cosmic Evolution Early Release Science (SEERS) survey. No deliberate mechanism or engineered pattern was present, and the waveform harmonics did not react to Webb's positional changes. The hypothesis of an interactive signal is not supported by current data,